Unit 16, Chemistry in Everyday Life. What is the use of chemistry in everyday life? That's what we have to study in this chapter. Okay, let's move on to this chapter. By now, you have learned that the basic principle of chemistry and also realized that it influences every sphere of human life. It means the chemistry is used all over the world and realized the influence of every sphere on human life. Human also is composed of this chemistry. So we have to learn about this chemistry. The principles of chemistry have been used for the benefit of mankind. Actually, chemistry was derived due to the benefit of mankind. It's actually been what we call established to benefit the mankind. Think of cleanliness, the materials like soap, detergent, household bleaches, toothpaste. Yes, what are the useful benefits for humankind? Yes, we can clean ourselves by soaps, and also our clothes by detergents. Our household bleaches are used for cleaning our houses. Toothpaste are used for cleaning our teeth, like that, etc. So many are there for cleanliness. That's why the chemistry is also useful. Will come to our mind. Look towards beautiful clothes. Immediately, chemicals and synthetic fibers used for making clothes and chemicals giving colors to them will come to your mind. Yes, what's the if you put the clothes you like that you like your favorite clothes, but what's there? What's that? Yes, it is composed of chemistry. The nylon, polyester, anything. It is composed of some chemical structures, right? And the dye colors what we used in your clothes are also made of by the chemistry. So it is used in everyday life. Immediately, chemicals of the synthetic fibers. Okay, it's completed. Food materials, again a number of chemicals about which I learned in the previous unit will appear in your mind. Of course, sickness and disease remind us medicines. Yes, in food also we useful, mainly them in the medicine field. It was huge useful. Again, chemicals, explosive fuels, rockets, propellants, building and electronic material. Yes, in the border side we use the weapons for to destroy the another country. So in that explosives are made up of some chemicals. Rocket propellants to establish over the satellite connection between the countries and the world to communicate. That also belongs to the chemistry field. Next, building electronic materials, etc. are all chemicals. Chemistry has influenced our life so much that we do not even realize that we come across chemicals at every moment. That we ourselves are beautiful chemical creations, and all our activities are controlled by chemicals. Yes, in the humans are also made of chemicals, and the human can perform some chemical in the inside the human. There are some chemical reactions has to be performing chemistry in three important and interesting areas, namely medicine, food materials, and cleansing agent. Yes, the main beauty of the chapter chemistry is that is medicine. It saves the life of thousands and millions of people. Without this chemistry, there is no medicine occurs. Actually, Ayurveda is there, but Ayurveda is also belongs to the chemistry. In the leaves and the any roots that is composed of chemicals that was known by Shishrut and other doctors. Yes. Next, the first classification, drugs and their classification, that is 16.1. Drugs are chemicals of lower molecular masses. Is first we have to list out the points. First, list out the name, that is drugs. In that drugs, it is the lower molecular mass. Okay, what's that size? It is approximately equal to 100 to 500 unit mass. Okay, you already learned about unit mass in the chemistry in the first chapter, basic concepts of chemistry. Okay, these interact with macromolecule targets and produce biological response. Okay, what are drugs? Drugs are the chemicals of lower molecular mass. These interact with macromolecule, not the micromolecule, macromolecular targets and produce a biological response. Yes, when these biological responses are useful for mankind, that if it treats the typhoid, malaria, and any other today's no coronavirus, then it is useful. Then it is called as medicine. Yes, that's what they are told. By first, drugs. What are drugs? Drugs are the lower molecular mass. Okay, you already know about these lower molecular mass. What we call interact with molecular target. If it is like this, interact with this molecular target and produce biological response. It makes this biological. Sorry for the interruption, guys. Okay, and let us continue this. These drugs are lower molecular mass interact with macromolecular targets and change this macromolecular target to function differently. That it means it changes the biological presence of humans or animals or anything. Then it is useful for mankind, or it responses is therapeutic. Then these chemicals are called medicine. Okay, you get two definitions. One is drugs and medicine. Okay, drugs and medicine. What is drugs? Drugs are the lower molecular mass, interact with macromolecular targets and produce biological response. But all the chemicals are medicine? No, all the chemicals are not medicine. What are medicines? Then medicines are the chemicals in which these chemicals are biologically responsive in therapeutic and useful. Then it is called to be medicine. Okay, you make out a difference between drugs and medicine. And are used in diagnosis, prevention, and treatment of diseases. Yes, as I already told, it is used in the diagnosis, prevention, and treatment of diseases. It is useful if taken in dose higher than the recommended. Most of the drugs used as medicine are potential poisons. Yes, is these medicines are useful? Example, if you are suffering from cold, then you take some medicine. If you take the doctor suggests one medicine, one medicine to take at night. But if you are suffering from eye cold, what you will do? You will take 10 medicine instead of taking one. Is this cure your cold in 1 day or 1 hour? No, it actually returns, makes your cold fast, and also it causes side effect, that is it is become poisonous to our health. So that we call it as dose. What we call is one medicine. If we take instead of one medicine, if we take 10 medicine, that is called dose. If the dose is higher than the recommended, then it also turns to be potential poison. Okay, if we take a dose higher than recommended, most of the drugs used as medicines are potential poison. Use of chemicals for therapeutic effect is called chemotherapy. Okay, I already told here what we called when the biological response is therapeutic. Yes, that use of chemicals in therapeutic effect is called chemotherapy. Okay, in this we have learned four. One is first you have to remember this. You don't have to forget on this. First, drugs. What are drugs? Medicine. Difference between drugs and medicine is all the medicines are drugs or all the drugs are medicine. Then you learned about that high dose, and also you learned about chemotherapy that has actually introduced in this medicine definition. Okay, let's move on to next page. 16.1.1 Classification of drugs. Drugs can be classified mainly on criteria outlined as follows. Yes, drugs are classified as these three: 1A, B, C, on the basis of pharmacological effect. Yes, pharmacological effect. The classification is based on pharmacological effect of the drug. It is useful for doctors because it provides them the whole range of drugs available for the treatment of particular type of problem. For example, analgesic, pain killing effect, antiseptic, kill or arrest the growth of microorganism. Okay, on the basis of pharmacological effect, P. Let's denote it by P. Pharmacological effect. This classification is based on pharmacological effect of drugs. It is useful for doctors because it provides them whole range of drugs available for the treatment of a particular type of problem. Example, if you have some pain, then you will take analgesics. The doctor suggests analgesics. If you don't have much knowledge, you have to be separate where is the pain in the leg or hand. Then we have to look for the leg, what may be the medicine better for this, how to release this pain in leg at a particular side. But on the base sorry, on the basis of pharmacological effect, the doctor came that for them whole range of drugs available for the treatment of a particular type of problem. Okay, we have to remember the main thing is analgesics have pain killing effect, antiseptic kill or arrest the growth of microorganism. Okay, P A E pa. Okay, pa. Okay, what do you mean by pa? Actually in you can call our father as pa. Remember this. What is P? Pharmacological effect. What is A? Analgesic effect. What is another A? Antiseptic. Okay, this analgesics help in pain. Here you can relate it. Yeah, after the you can relate it as pain. What is this A? This A stand for microorganism attack. Okay, pa. This whole thing is represented by pa. Don't remember this. Remember this only. This much. This one. It's efficient. Pa. What is pharmacological effect? In this pharmacological effect, it is wide range used for doctors to treat the some kind of problem. Okay, what are the problem? Some of the examples have to be given. Antiseptic and analgesics. Analgesics are used in the pain killing, but antiseptics are used in the attack of microorganism. Okay, this sentence is don't remember all the sentence, remember this word only. Next, on the basis of drug action. It is based on the action of a drug on a particular biochemical process. If some of the biochemical process is taking from here A plus B is giving C, this is called as a biochemical process. Actually it is general form. It can be of any type. There are so many chemical reactions occurs in that the changes, but here it is based on the action of drug on a particular biochemical. Actually, as I told, if A plus B is giving C, it acts on this reaction. It acts on this biochemical process. For example, all antihistamines inhibit the action of the compound histamine, which causes inflammation in the body. Yes, in some of the parts of the leg or in the hand, we feel inflammation, that is burning sensation in our body. This is due to histamine. Some of the reaction is taking place in histamine. Actually, some histamines are making this sense, right? Histamine is making this sense. But if we take antihistamine, the biochemical reaction would change. Biochemical reaction would change this process. Okay, this antihistamine performs a very major role, and it decreases and it stops the inflammations in our body. Okay, that's why antihistamines are useful. There are various ways in action of histamines can be blocked. You will learn about this section 16.3.2. Antihistamines is there only antihistamines are the only solution for this inflammation, to decrease the inflammation in our body? No, there are other methods also there. We will learn about this in this chapter only at 16.3.2. Okay, what do we represent this sentence? I need to represent this sentence by 2 words, that is okay, drug action histamine. Dutch. Okay, Dutch. What is mean by Dutch? Drug action antihistamine kills the action of histamine. That's Padhaj. Pa, and this is represented by Daj. Drug action. What is in this drug action? What is the main thing? And antihistamine. Antihistamine acts on what? Histamine only. That's the thing. Okay. On the basis of chemical structure, yes, on the basis of chemical structures also drugs are classified. It is based on the chemical structure of the drugs. Drugs classified in the way share common structural features and often have a similar pharmacological effect. For example, sulfamides have a structural feature given below. Yes. This is the sulfamide. Structural features of sulfamide. On the basis of chemical structure, it means it is based on the chemical structure of the drug. Drugs classified in this way share common structural features and often have similar pharmacological activity. Yes, sulfonamide has performed same activity and another chemical also perform same activity. That is, take example XY. This is also have same structure like this, and both perform as in told pharmacological PAA, antiseptic or analgesic. In analgesics, it pain kill. So if these both perform the same activity having same structural formula, then it is based on the structural features of structural features. Okay, that is the basis of classification. Yeah, if you need, you have to remember this chemical formula. NHR, NH2, it is attached to benzene. Okay, it is attached to benzene. Sorry, actually it's not benzene. I think 1 2 3 4, sorry, it's benzene, but actually I wrote like this. If I wrote like this, I will get the benzene. Okay. In this, what you have to remember: chemical structure. CS. Who is CS? Actually, in Kannada industry, there is one of which is a Shetty person. You can remember the name also. CS. What is CS? Chemical structure. On this chemical structure, what is the important structural features of sulfamide? Okay. CS. On the basis of molecular targets, drugs usually interact with biomolecules such as carbohydrates, lipid, protein, and nucleic acid. These are called target molecules or drug target. Drugs possessing some common structural features may have the same mechanism of action on target. The classification based on molecular target is the most useful classification for medicine chemistry. Yes, you already learned about this in biology. In that some of the enzymes perform some activity, the substrate fits into this and perform the reaction faster. But what happens is molecular target, these molecular target drugs actually inhibit this. It inhibits this place and arrow, or it fights with this substrate, or it will fit into this and changes the active site of the enzyme. That is clear with this molecular target. Drugs usually interact with biomolecules such as carbohydrates, lipid, protein, and nucleic acid. These are called target molecules of the drug. What is target molecules? Drugs are usually interact with biomolecules such as carbohydrates, lipids, proteins, and nucleic acid. These are called target molecules or drug targets. Drug possessing common structural features may have the same mechanism action on targets. The classification based on molecular target is the most useful classification for medical chemistry. This is the most useful classification for medicinal chemistry. Okay, let's move on. Drug target interaction. What is drug target interaction? Drug and target interaction. Yes. We have learned about what you call Oh, molecular target. Yes, I think I didn't mention any name for this molecular target. MT or gulab jamun. This is the best way to remember. MT molecular target represents the carbohydrates, protein, lipids, nucleic acid. Drug target interaction. Macromolecules of biological origin perform various functions in the body. For example, protein, which perform the role of biological catalysts in the body, called enzymes. Yes, I actually told in the MTR, that is molecular target classification. If it is the protein which performs the role of biological catalyst in the body are called enzyme. This enzyme is a protein which perform the role of biological catalyst. That inside, if it, substrate fits in this, the reaction takes faster than anything, and these are called enzymes. Those which are crucial to communication system in the body are called receptor. Yes, if we touch the hot body, then our hand will be taken return. This is due to the receptor action. Those which are crucial to communication system in our body are called receptors. One is for biological study. Enzymes are useful to take test reactions faster and to sense our surrounding. The receptors are useful for communication in our body. That is, neural system are also helpful. To the neural system, the receptors are the main communicator for that. Okay. Carrier proteins carry polar molecules across the cell membrane. Yes, some of the carrier proteins carry polar molecules across the cell membrane. In human body, there is no cell wall present, only cell membrane. So in this cell membrane, carrier proteins carry polar molecules. Polar molecules are carried in the cell membrane. Okay. Nucleic acids have coded genetic information. Yes, in DNA or any other structure, we will find some of the coding happens here. This makes our genetic same for our parents. That coded genetic information for the cell. Nucleic acids have these coding in genetic information of the cells. Lipid and carbohydrates are the structural parts of the cell membrane. What is this cell membrane composed of? It is composed of lipids and carbohydrates. We shall explain the drug target interaction with the examples of enzymes and receptors. Yes, what will be the useful use of these drugs in this body? Yeah, we have to learn about from the next upcoming pages. Okay. Enzyme as drug targets. Catalytic action of enzyme. For understanding the interaction between a drug and an enzyme, it is important to know how do enzyme catalyze the reaction. Section 5.2.4, in their catalytic activity, enzyme perform two major functions. I actually told that, but they are given. Let's start. The first function of an enzyme is to hold the substrate for a chemical reaction. Yes, I told that if this is an enzyme, it holds tightly the substrate. This is the substrate. This is the substrate. And this is the enzyme. If this enzyme holds the substrate molecule, active sites of in this here there is active site of enzyme. Active sites of enzyme hold the substrate molecule here and also here. This active site, this is called active site. Active sites of enzymes hold the substrate molecule in a suitable position. Yes, in the suitable position it can hold, because to maintain the grip, it does not want to take place until the chemical reaction completes. So it holds it properly. So active sites must be having some suitable position so that it can be attacked by the reagent effectively. Okay. Yes, that's what actually diagram the textbook has given. Substrates bind to the active site of the enzyme through a variety of interactions such as ionic bonding, hydrogen bonding, van der Waals interaction, dipole-dipole interaction. Actually, we have doubt. Some of the people ask how this substrate fits into this, or how it actually binds into the active site. The answer is it actually takes place by the hydrogen bonding, ionic bonding, or van der Waals. It is a weak interaction, or also or dipole interaction. Through this, any one of these process, the substrate will fit into the active site of an enzyme. This is, you can see that this is a substrate and this is an enzyme, right? Next is the second function of an enzyme is to provide the functional groups that will attack the substrate and carry out chemical reaction. Yes, this is very important. The second function of an enzyme is to provide functional groups. It will provide some functional group, that is OH, CHO, NO2. Some of these is some of the functional groups that will attack on the substrate and carry out chemical reaction. Yes, after giving the functional group to the substrate and it what we call carry out the chemical reaction faster and giving more quantity at only less time. Okay, you understood about this. Next is drug enzyme interaction. A drug inhibit any of the above mentioned activities of enzyme. Drugs inhibit the above mentioned activities of enzyme. This can block the binding site of the enzyme and prevent the binding of the substrate, or can inhibit the catalytic activity of the enzyme. Such drugs are called enzyme inhibitor. This is the most important, you have to remember. Drugs inhibit the above mentioned activity of enzyme. Yes, this is the not. This is the process actually taking place in the above diagram, but in here the drug interrupts this. Instead of substrate going to fit into this active site, drug will go and sit into this active site and changes the chemical reaction. This can block the binding of an enzyme and prevent the binding of substrate, and can inhibit the catalytic activity of enzyme. This inhibit the catalytic activity of enzyme. What is the catalytic activity of enzyme? I already told. It releases some functional group and carry out the chemical reaction, but it inhibits this chemical reaction by binding the drugs and inhibit the catalytic activity of enzyme. Such drugs are called enzyme inhibitor. These drugs which inhibit the sorry for that. These drugs inhibit the binding of substrate and stops the catalytic activity of enzyme. Then it is called as enzyme inhibitor. Drug inhibits the attachment of substrate on the active sites of in two ways. Actually, it takes place in two ways. What are the two ways? Well done. Drugs compete with the natural substrate for their attachment on their active site of enzyme. Drugs compete with the natural substrate for their attachment in their active site of enzyme. Such drugs are called competitive inhibitor. Yes, if these drugs compete with this substrate, I will go and I will go there in the active site, but a substrate else I will also go there. But in these, if the drugs win, which the drugs compete with this substrate is called as a competitive inhibitor. Okay, that drug is called as competitive inhibitor. First classification is known. What is first? That is competitive inhibitor. This is the natural this is the drugs that compete with the natural substrate for their attachment to active site of an enzyme. Then it is called as a competitive inhibitor. Seeing figure 16.2. Here you can see this drug is actually competing with this substrate to fit into the active site of an enzyme. Next, another classification. Some drugs do not bind to the enzyme active site. These bind to a different site of an enzyme, which is called allosteric site. This binding of an inhibitor at allosteric site changes the shape of the active site in such a way that substrate cannot recognize it. Yes, actually, we told that if the enzyme is there, it should hold the substrate with a high grip, which do not escape when the reaction is taking place. But here, the inhibitor attack into this allosteric site. Yes, in this allosteric site, if it attacks, it changes the shape of the active site. In this active site, it cannot fit the substrate perfectly. Actually, I told that you can see here. Where I told that yes, yes, here is the final that will attack and carry out chemical reaction. Van der Waals forces attached by. If 1 minute, I will find. Yes, here is there. Active site enzyme hold the substrate molecule in a suitable position. But what happens here? In here, the suitable position is not occurs because the allosteric site it is attacked by inhibitor, so it changes the active site shape, and this in active site shape this changed shape does not make holds good for the substrate to bind it. So the chemical reaction stops. That if some of the chemical reaction making our body unhealthy, then it is stopped by these inhibitors. Okay, in the one of the first one is competitive. It competitive with the drugs that involve in the. Yes, 1 minute. Sorry for that interruption. Competitive inhibitor. These drug which compete with the substrate of which fit into the active site of enzyme, and it overtakes, and it the drug will fit into the enzyme. Then it is called competitive inhibitor, and the next step is fitting into the allosteric site by one of the drug and changing the shape of the active site of an enzyme that it is not always good for substrate to fit on that active site. Then it is said to be that's allosteric site. Okay, here is the given, right, the shape of the active site in such a way that the substrate cannot recognize it. Okay, the substrate cannot recognize it. If the bond formed between the enzyme and an inhibitor is a strong covalent bond, okay, and cannot be broken easily, then the enzyme is blocked permanently. Yes, if this inhibitor if this inhibitor fits into the active site by forming covalent bond, and it permanently breaks down the activity of an enzyme. It is blocked permanently. It cannot be broken easily because the covalent bond is not broken easily. If it is van der Waals force, it can be easily removed, but it is covalent bond, so it cannot be easily removed. So enzyme is blocked permanently. The body then degrades and the enzyme inhibitor complex and synthesizes the new enzyme. Okay, then the enzyme is blocked permanently. The body then degrades the enzyme inhibitor complex and synthesize the new enzyme, which make the body to synthesize new enzyme.